Hello gamers, this is FCast and Chill here. Today I want to talk about math again. I want to answer a simple question today, and that is, how likely are you to go dry on something? So any drop in the game, whether it's something that's pretty common like 1 in 2, 1 in 10, or even something really rare like a 1 in 5,000, how likely are you to go dry on it? And just to clarify, by dry I mean how likely are you to not have the item once you get to that item's kill count. So if you're looking for a 1 in 1,000 drop, what is the chance that you get it by the time you're at 1,000 kill count? So that's what we're going to look at today. Let's start with the simple example. What if something is very common? What if it is a 1 in 2 drop? Then what's the chance that you go dry for it? Well, think of it as just flipping a coin. What's the chance if you're looking for a head that you don't get it after 2 tries? Well, that's simple. If the chance of getting tails both times. Each time you flip the head, or you flip the coin, there's a 1 in 2 chance you don't get what you want. And since these two flips are independent, you would just square that. So it would be 1/2 squared, or 25%, that you don't get a heads after 2 coin flips. Now let's look at a slightly more complicated example. Let's think about a 1 in 10 drop. How would you calculate the chance of not having it after getting 10 kill count? So let's take a look there. Alright, so each time that you attempt to do this 1 in 10 drop, there is a 9 in 10 chance of not getting it. And each kill, we can multiply that chance together. So you have a 9 in 10 chance of not getting it after the first kill, of not getting it after the first and the second. It's 9 in 10 times 9 in 10. After the third kill count, we'd add another 9 over 10, and then so on. So we would actually, to calculate the chance of not having the item after 10 kills, we would have to multiply 10 of these together, so it ends up being 9 over 10 raised to the 10th. So really, for any kill count, if you have a kill count x, where x is the drop rate for this item, it could be 1,000, 5,000, etc. The chance of not getting the item on any kill is going to be x minus 1 over x, and the chance of not getting that item after doing x kills, you'd have to raise that to the power x, because we'd multiply all those probabilities together. So this right here, this x minus 1 over x, all raised to the power x, that's the probability of not having a drop once you're at the kill count, where the kill count is x. So let's actually look at this on a graph now to see what this looks like. So here I've plotted this function, y equals x minus 1 over x raised to the power of x. And you can see here, when x is 2, we have the 25% that we talked about. Remember the coin example, flipping tails twice in a row. And you can see as the kill count increases, so as if the drop rate was 1 in 10, then we'd be up here somewhere a little over 34% chance. So that means there's a 34% chance you will not have the item once you're at 10 kill count. So does this keep increasing? Does it stop somewhere? Let's look a little closer. So I have another graph up here, and this is actually going from 200 on the x-axis at the start point up to 10,000. And so this is going to be the majority of drops in the game, are going to be in this range from 1 in 200 up to 1 in 10,000. And you can see that the difference between these is actually very small. This y-axis, the scale is shifted. So down here we have about 0.3677, and up here it's just barely higher, 0.36785. And so if something's a 1 in 10,000 chance of dropping, once you do 10,000 kill count, you have about a 36.8% chance of not having that item. And you can see there's actually an asymptote right up here. So no matter how high the kill count or the drop rate for this item gets, by the time you do the kill count of that item's drop rate, you will have only about a 36.8% chance of not getting the item. What's actually really interesting is that if we take the limit of this, so if we do the limit as x goes to infinity of x minus 1 over x all raised to the x, this actually approaches the number 1 over e. So I don't know if you guys know what e is, but it's actually just a number just like pi is, just a irrational number. And it's about equal to 2.718. So it's actually really cool, in my opinion, that e just shows up in nature like this in this natural probability problem. But as you can see, for all of these, this is very close to this 1 over e, because 1 over e is actually equal to about 0.368. So really, for any drop in the game, this is the answer here. So this is your final answer here. For any item in the game where the drop rate is over, maybe 10 or 20, then once you're at the drop rate, your chance of not getting that item is about 37% here. And so really, if you think about it, that's about a 1 in 3 chance. So that means with each grind you do in RuneScape, on average, you are going to go dry for about 1/3 of them, which sounds kind of unfortunate if you think about it. Yeah, that's really all I had for today. I have another math video idea that's kind of interesting that I could talk about next time. Let me know if you're actually interested in that, if you like it. Yeah, I guess that's all I have for today. I'll be back with the PVM guide soon too. And yeah, let me know if you have any suggestions or comments. Go ahead and leave them below. And then if you don't mind, if you enjoyed this video, please like and subscribe the channel. It'll help it grow, and I really appreciate it. All right, take care.